More than 70% of Earth is covered by ocean. Yet most of it remains unexplored in the depths. Sound travels farther than light, and sometimes it reveals events we never witness. This series examines unexplained sounds recorded beneath the sea. This is Abyss Whispers. In June 1997, a network of underwater sensors recorded an unusual sound. It was detected independently by multiple hydrophones in the Pacific Ocean. The signal was exceptionally powerful, strong, enough to be recorded more than 5,000 kilometers from its source. Sound would later become known as the bloop. Light penetrates only a short distance into the ocean. Vision becomes useless. Sound, however, travels efficiently through water. For this reason, scientists rely on acoustics to study deep ocean activity. Earthquakes, ice movement, marine life, and human activity all produce distinct acoustic signatures. The sound was recorded by hydrophones, operated by the National Oceanic and Atmospheric Administration. These sensors were originally deployed during the Cold War. Their purpose was to monitor submarine activity. In 1997. They were also being used for scientific research. The bloop did not match any known acoustic pattern in NOAA. The signal lasted over 1 minute. It occupied an extremely low frequency range. This suggested a very large source. Initially, researchers considered several possibilities. Mechanical sources were ruled out. Marine animals were also considered unlikely due to the scale of the sound. One hypothesis involved a biological source. However, no known species could generate a signal of that. Another explanation focused on geological activity beneath the ocean floor. A third theory suggested ice-related events in the Southern Ocean. At the time, no single explanation accounted for all observed characteristics. Further analysis and additional data eventually led scientists to a conclusion. The bloop was identified as an icequake, a large fracture of Antarctic ice interacting with ocean water. Over long distances, sound waves can distort and change frequency. This explained why the signal initially appeared unusual. From a scientific standpoint, the case was resolved. Although explained, the bloop remains significant. It demonstrated how little of the ocean we directly observe. It also highlighted the importance of acoustic monitoring. Many underwater sounds are still detected before they are understood. The ocean continues to record its own history. We are only beginning to interpret it. The ocean is constantly in motion, and it is constantly being recorded. In the next episode, we examine another sound from the deep. Until then, this has been Abyss Whispers.